I'm so old now that I forgot what Amy's question was. Hold on, don't tell me. Don't tell me. It
I'm gonna tell
was
you.
no. Hold on. Give me a
No,
second.
I'm gonna tell you.
No, give me a
No,
second.
I know.
Um.
Why is it necessary for
Oh
the
yeah, but no, that's the
compiler?
thing. I know,
Okay.
no. It's the thing. It's the thing with
Ah,
the
okay,
constructor thing.
wait.
Great way to start the recording.
Actually, we can. I think it actually might be easier to just do it this way instead. I think. And so let's try to write a program that doesn't do what I say. Right. So we'll take this stuff here. I'll take this out, and then we'll say class A like that, and then we'll say class B extends A like that. Now, if I compiled this, what would I get? Or we can try. Two empty classes. Well, apparently my compiler has gone on vacation already by the look of it. No, but we wouldn't get to, oh, you know what? Where are we here? Oh, we're in the right place.
Aren't you supposed to use the? You're not going to use the reference.
That is my reference.
Oh, it says Espresso C.
Yeah.
Oh, okay. So yours is this.
I
Okay,
am the
gotcha.
reference, right?
Okay, gotcha.
But apparently, I mean, this thing must have gone on vacation. What the hell is going on here?
Did you break it again?
No, but it's just nothing. It
Oh,
all
okay.
runs like
There,
it's
there you go.
molasses, right? I don't know. There's a lot of stuff that's running awfully. Let's try that again. There we go. Right. Grep dash v b dot rj. So, and let's do the same for a. So look, I didn't get an empty class. I got one with a default constructor in, and this is, I think, was Amy's question to begin with. Why, why is this thing created? And actually, if I compile this with Java, they wouldn't be created. So I think if I said Java p-c a. Oh, that one is. Oh, I guess you do get them. All right. Well, fair enough. So there's A and there's B. Now, why do we do this? Well, if I look at this and we agree that we're going to generate these automatically generated default constructors. So that basically means if I wanted to mimic this in code, I would do something where I say public B nothing, and I do that. And up here, I would do something where I say public A like that. Now, why is that no different than what we already had? Well, because that's exactly what I had here, right? It's what is this? This is B, right? It has an initializer, takes no arguments, and does nothing. Well, it does do something. It calls that. Right. So let's assume that I didn't do this. If I did this, this would, just to prove it, would actually generate the exact same code. We can just see that here. See, that's the exact same code as we had before. But now let me take this one out. And let's assume that none gets generated for A. We can actually go in and rip it out and see what happens. Let's say that I want to put a special one in here that looks like something like int x, and then we'll take in an x here. And then we shall say this dot x equals x. Everybody okay with that? That seems reasonable too, right? Will this compile? Let's just look at what the code that we got generated. We got that. So the question is, why on earth do I need that one? Well, then maybe we don't. Let's go in and take it out. See what happens. Just check that out. There we go. Jasmine a.rj and b. Oh. maybe we need a public static void main string args. New bb equals new b7. There we go. Compile that again. Sorry about that. Emacs a.rj. We are going to rip that out. Jasmine a.rj, and we will do b.rj, and then I'm going to say espresso b. What happens when I run this? Hold on, I'll let you look at this. Yes, some error will happen, but what error will happen? Why is this not going to work? It's all about, well, no main. There's a main right here. Look. Public static void main string args. Presley says no constructor for A which B will try to use. Yes, indeed, that is the problem. But why is B trying to use a constructor in A? Super. Right? It's what you don't see. Because if you don't put in an explicit constructor invocation, what do you get? You get that. Where is that super? There's no super there, so let's just try running it. Look, no such method found. A method void in it not found. So, because if you extend this class A has to have a constructor of some sort, because there has to be the ability to do an unbroken call chain of constructor calls from whatever you're instantiating all the way up to object, right? So since A doesn't extend anything, it's as if we said extends object. So we got to be able to call through A, so there has to be at least one constructor. If there's no constructor, you can't instantiate it. And if there's no constructor, you can't extend it because there's no way to call through because you need a constructor in there. So the rules were simply, if you don't put anything in, we will put something in for you. And what we will put in looks like this. Public void A, nothing, super, blah. So that is actually what the default constructor that you get from the compiler looks like. Now, if you put in something like this, what's going to happen then? Will this code compile? No, because this is going to look for a default constructor. But you don't get a default constructor if you put in non-default constructors. Which one do you not like? 3, public void A, my. Oh, there we go. Jasmine a.rj, b.rj, and espresso b. Actually, why did that work? That shouldn't have worked. Where'd that come from? Oh. There's a check that the compiler doesn't do. This is bad. Let's write that one down. class A public void A dying little green notes in here. Right, so if I did that, then of course we should get a different error from the compiler when it says there is no default constructor and the default constructor is the one that I'm using here. So what I can do is I can either go in and put this super in as something that takes something in, but now if I do another one, if I put a default constructor in that one, this won't compile either for the exact same reason. It says, well, there's no constructor like that that's found, and it's missing from here because this has this call there, right? So it's a good thing that Amy showed up so you didn't have to write all this down. Yeah, everybody happy with that? Let's see, what do we want to do? Well, I suppose we could something with live sets. Okay. See if I can find a good one. Well, I suppose we couldn't we just make one? So let's see. So what are we trying to, let's see, so we'll have X, Y, and Z, and then we shall say X equals 0, X equals 100, say while X is greater than 0, then Y equals half of X, and Z equals Z plus Y. And then here we'll say, I don't know, Z equals Z minus X. How's that for an example? So let's try that. Grab dash V. Test 1, 2, 3, okay. Just get rid of all this gunk up there. Try to grab that and right. So let's see. We need a basic block there, 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 there. And should we put one in there for good order? And then I'll adjust these to look nice. And then we'll call that one B0, B1, B2, B3, B4, B5, B6, and what we shall do as well, since we need these, we need use set, and we need a def set. So that's going to be of that thing right here. Right, so what variables are, actually, should we just write down here as well? Oops. What is it? What to play? We can do this with 1, 2, and 3 if we wanted to, but so address of x is 1, I think. Yes. Address of y is 2, and the address of z is 3. So what does this instruction use? Nothing. What does it define? Nothing. Which one does this one use? Nothing. Which one does it define? It defines x. What does that do? Well, it uses the one at 1, so that's x. What does it define? Nothing. That one here uses nothing and defines nothing. This uses, actually, I think many of them are going to be like that. That doesn't use or define anything. That doesn't use or define anything. That doesn't use or define anything. Neither does that. That one does. That one loads x. Icons 2 doesn't do anything. Div. Dabs, whatever that is. Store, well, that must not use, but define, and it's 2, so it's y, isn't it? Yeah. I load 3, that loads z, and doesn't define anything. I load 2 uses y, and nothing. I add 1, so not 1, just I add. I store 3 uses nothing, defines z, go to nothing and nothing. And what do we got here? That's going to be z. That's at 3, right? 1, 2, 3, yes. And this is x. Yeah. And nothing. Nothing. That's the store. Nothing. Z. And nothing. And nothing. Cool. So what now? Well, we probably need a control flow graph of some sort. If I put these side by side, can you actually see both? Cool. So let's just do the control flow graph so that we know what it looks like. So that's B0. What happens to B0? Well, it flows into B1. What happens to B1? It goes to wherever L3 is, which is B3, or it falls to B2. So B2 or B3. What happens to B2? It goes to L4, which is B4. And what does B3 do? Well, it falls through to here. What does B4 do? It jumps to B6 or B5. Something like that. My boxes are getting slightly smaller here. So B5. B5, B6. What does B5 do? It goes to wherever L1 is, which is in B1. So that goes up there. Right. So what we can do is we can start here, right? So we can start by saying, let's assume that we have a live out set there that is empty. Cool. So we'll assume that the live outs of all of the instructions are empty to begin with. So if I did something like this, when I say live out season 0, so those are all that. Oops. Actually, let's not bother. Let's just assume that they're all 0. ... Right. So now live out season 1, and we'll start down here. And of course we had that there. So what is this going to be? Well, it's going to be the previous one.
Are you just saying that you initialize all of them to be empty before you fill it in?
Yeah, that's perfectly
Okay.
That's perfectly fine to do that, right? So now we have our formula, which I suppose we can write right over here somewhere. Let's just see. Yeah, I think we can do it here. And what does that one look like? Well, it says something along the, well, so we should do insets instead of outsets, shouldn't we? But in order to do insets, we sort of need that last outset. We'll do live in. Deal with it. So let's just forget about these 2 lines and say live in first iteration. Now, when let's look at that last guy down here, right? If we look at that return, so if I have, let's just sort of blow this one up, and it's something return, and that's the end of that story, right? So what I want to compute there is now this one here, which is live in of that return. Well, what is that? Well, it's that value there, isn't it? That we need. So we need something here. And if it's the end of the thing, the end of the code, we'll just do it like that. So it's that minus what's defined by the return statement plus what's used by the return statement. Now, of course, that is a empty set, and that's an empty set, and the overall thing is an empty set. So we get an empty set there. So we kind of have to have something, after the last instruction in order to get this thing going. But now we should be able to do this for these individual things. So we're going to assume that we have an empty one down there. So it's that empty one minus that one plus that one. Well, that gives me an empty. Cool. What about this iStore? Well, it's this one minus that one plus that one. Well, that's awfully empty as well. What about this one? Well, it's an empty minus an empty plus an empty, so that's fine. What about this one? That's an empty minus an empty plus x. That's that one. What about this one? It's x minus an empty plus z, x, z. So now we are here. And we have x, z. So if we think about what happens when I go to deal with the last thing in B4, which is this guy here. Well, in order for me to compute this properly, I really need to have computed the Leibniz set for this guy, because looking here, we can see that I need a set here as well, but I don't have anything there. So, you know, I can just continue as if, you know, nothing had happened yet. Well, nothing has happened yet because we haven't gone around. So we'll just continue upwards here. Now this guy here comes from up here somewhere, right? So we'll just we'll take the oops, where, oh, there it is, my cursor. We'll take the empty set again, and then we'll say, well, it's minus an empty plus an empty. That's fine. This is minus z plus an empty. That's fine. This is fine. Minus def plus u, so we get a y there. We have a y here, so we get y and a z. And then it's minus def plus u, so we lose the y. And that doesn't do anything, so we retain our z. And the same here. And then we get a z and an x. There we go. Now, what we could do here for this guy is we can just start with an empty one, and as next time we do the iteration again, eventually we would pick it up. But we kind of know now when we do this B4 that we need to do something with these guys, so we might as well use them. So I know that at that point I had, oops, Z and X, and especially because it's the same in both of them. So we'll just use those and plug them in there, right? Now what happened before L4, B4, that goes to B2 and B3, so B3 also gets the Z and the X, and B2 gets the Z and the X, and so does this guy. Since there's nothing in their def or use sets, nothing else happens. This one here, L1, is in B1, that jumps to B2, B3, but both B2 and B3 had that as well, so we can just drag that up with us. ZX, and what do we get here? We get ZX, and then we get there, we get ZX minus nothing plus X is still Z and X. And then now we look at this graph again and we say, all right, really what I should have done here when I did, or sorry, when I go and look at this graph, I need to take into account, well, actually what I need to do is when I do B5, I need to take into account what the top thing is here. So really, in the next iteration, we need to take a look at that and use that when we're down here to compute the next set. So if we do that and we come down here and we say, all right, so now we have to compute this. So I need the previous one, but there's more than one previous one here, right? There's both. Where am I coming from? There or there? Oh, sorry, it's the other way around, isn't it? Did I get this right? Yeah.
B1 should be the only one, right? I think so.
Well, no. So you know, if we actually look at the example, let's still not build that example. 8.5. You can see we do it a number of times there because we have the arrow that goes around, right?
Yeah, it keeps updating it.
Yeah.
Yeah.
And so it's just a question of where do we need to. So we're going against the arrows, right? So in order to do B4 here, for example, I use those two because they point away from it. In order to do B1, I use those two because they point away from it. And in order to do B5, I needed that top one, but that one was empty to begin with, right? When I did this B5 here, we started out by saying, oh, that was empty, but that's not the case anymore now, because that one there is the one we get there. So we really have to redo this with ZX, and then we get up here and we get minus Z plus nothing, so that's X, 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 Y, X, Y, Z, X, Z, X, Z, X, Z. We should have just finished that one off, the last one, but that's right. And X, Z. So we can see now that we actually ended up with the same thing here, right? So there's really no need to continue up here because we'd end up with the same thing anyways. The only place where things changed was basically in here, right? So if we go up here, where did we come from? Oops. Oh, that one, I forgot to give it a name. Hold on. CS460, May 4, I would say Star Wars Day today. So for the B0, we only have to worry about that one, and that is minus X. We retain the Z, yeah. Yep, so we probably don't need that. And that's Z, which of course, if I wanted to do the live insets for the second generation around, we'd end up with the same thing. And then if you did them one more time, then you'll see you end up with nothing changing, except for the fact that I put Z first there, but that's okay. That's sets, it doesn't matter. There we go, and we get a Z there, and we get a Z there, and this is live in 2. So we get something like that, don't we? Now, if we just look at that code, does that make sense? So this tells us that it is possible that Z is not initialized. Is that true? Yes, it is true, right? Because Z is read there. And even if I don't go into this while loop, if I go into the while loop, there's a problem there. If I don't go into the while loop, there's a problem there, isn't there? What about X and Y? Well, Y is definitely assigned there, but since it's never used down here, it's not a problem that it's uninitialized, right? Because Y is never actually read, so, except for here, but there's always a definition before it there. And what about X? Well, X is always initialized there before it's being read there and there.
So should we want for the top instruction to be empty for the
Yes.
live set?
Oh,
Okay.
yeah. Because if it is not, then there is a path in the graph that leads you to a place where a variable is read, but on that path it was never assigned.
Okay, and this is a syntactic notion of liveness because we're just looking at the graph.
Yes, no, absolutely, right?
Okay.
Yeah, that is true. All these analyses are based on syntax. So the shape and form of the tree, the basic block control flow graph. It's not a tree; it's a graph. Sorry. So yeah, are we good then? Anything else? Oh, it's already 5:15. Is there anything else we need to do? Or should we call it a day?
Can you post Monday's lecture for us? I need it for study reasons.
I did.
Oh, you did?
I think I did yesterday. Pretty sure. Well, I did. Somebody asked me yesterday, so.
I can't find it.
Playlist. Did I upload it to the wrong playlist? May 2nd? It's there.
Okay.
Hold on.
Yeah, I don't see it on Web Campus.
No, but then go to the YouTube channel and find it there. It's probably because Ben forgot to link to it. It's right there. Thank you to Tony. There's a link in the in the chat, so grab it from there. Can you ask a question about phase 6? Sure, if it's a short one. Clear. Final is Monday at 6. Yes, it is Monday at 6. And come by here before. I will be broadcasting to you from an unknown disclosed location. Undisclosed unknown location.
He's in England.
Yeah, but you don't know where.
I'll find it.
Yeah, good luck with that. Even if I told you I was in London, you probably wouldn't be able to find me. Even if I showed you a picture out the window, you wouldn't be able to find me.
You know, I might be able to in that case.
Really?
It's possible.
Okay, I shall. When I get there, I shall take a picture out of the window and I shall post it, and you can try to find me.
Well, that doesn't mean I'm going to try.
So yeah, there's a subreddit for that. Yes, I know. I watch this guy on YouTube too who does where people send in pictures and he has to figure out where in the world they are, and he's surprisingly good at it. But I know, Zach, you would just go straight to the meta information to see where the picture was taken.
You know me so
yeah,
well.
the GeoGuessr guy, the British one, does the trek across Wales and all that stuff as well. Yes, Shirley, I am going to hold a study session on Sunday, and you would have known so if you paid attention, because we've talked about this 850,000 million times. It is already on the WebEx calendar and everything. So it's 10 a.m. on Sunday. Right. So I'm having trouble with the append function in String Builder. Under what conditions do I implement that method in phase 6? When you need is the I mean, that's not a particularly nice way to say it. But so let's take a look at this. Actually, let me just you know what? There's no point of me posting these notes, I think, because there's nothing, one page. So I'm not going to bother with that. Let me just unhook this stuff here, and then let's just take a look at what we got. Now, of course, we can use this one here, right? If I do this and you say something like string s equals hello, and then we say s equals s plus world. So let's do it like this. We do it like that, and then we say espresso C test 1 2 3 Java. We put in a proper end of file. Grep -v test 1 2 3 J. So you can see when I there's that first thing that says s equals hello, right? Then because I now start doing pluses, I use this string builder thing here. So because I have a plus between a string and something, I create a string builder. And it's important to realize that if you look at this, that string builder is created here. So the string builder is not based on the fact that that's that s there is necessarily a string, right? It's because I have a plus between two things where one of them is a string. So that requires a string builder there. And therefore, that needs appending, that needs appending, and that needs appending, right? And then by the time I get to the end, I can just do a toString, which leaves a reference to the appropriate string on top, and then the assignment can progress as you normally would. So look, we realize we're doing plus on something that involves a string. We create a new string builder. We're going to dupe that one because at some point I'm going to have to call toString on it down here. And then we're going to well, this is just a constructor, right? So now we have created a string builder. We've run the constructor on it. We have a reference to a string builder on top. So every time I call append, it actually leaves back on top of the stack a copy of itself, so I don't have to keep duping there. So that loads s. I'm going to append that. And the value that, or the type that goes here, depends on whatever type that is. So if I had done something like this, like that, then you can see my append takes in an integer. It's still append and returns an L-Java lang string builder. But because that was an integer, that's an integer. That is a string that fits with this. This is a string that fits with this. And then finally, I do the toString call when I'm completely done, and then I can store. So this actually, I think if we look, you can see that that's the end of the binary expression is there, and the binary expression, the first one, starts there, right? So the assignment ends in that A store, and that binary expression is the value of the thing on the right hand side. So from the point of view of doing this, that's not particularly hard. However, you're going to get into a little bit of, maybe a little bit of trouble if you try something like this. So I want to put some stuff in here. Now, if I do that, what should the output of this be when I run it? So if I say system.out.print line s and public static void, we already had void, main string args, yeah, that's fine, espresso c test 1 2 3 Java. Oh, I knew I forgot something. Import system Jasmine test 1 2 3 RJ espresso test 1 2 3. Hello, 5 world, right? So what happens if I look at this and I say, right, I'm going to create a string builder here. I'm going to append, 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 and append. Well, that would be basically the same as if I did that. And I do that, and I do that, and I do that, and I get hello 23 world, right? So because this expression here by itself is something that's involved in string concatenation, that's going to need its own string builder. So you can see, if you look at what I actually have here, we say if I compiled it and saved it, I keep looking at the wrong thing. Here we go. So look, there's my LDC hello. That stores to S. Then I create a new string builder, dupe it, and initialize it so that I can at some point do an A store there, right? So that's perfectly fine. There's that toString that we had before. Wonderful. A load 1 append, that's the S. Space append. Now look, 2 3 add, and then I append. So that gets taken care of first. What if I had 2 3 plus that? Then I know the way I did it was I just kept track of, is there a string builder alive, or active? So has a string builder been created? If it has, then if you're chugging along, and you're the one who created the string builder, then you can just use it like this. But when you get down here, that binary expression is is something that is added together. So that just gives a number, but you still have a string builder, so you can just keep adding things to that string builder. And by the time you're done, if you're the guy who created the string builder and you're at the very end, you can then just call toString on it, right? So let's see. So here's support for strings.